if you have a loop like this, see that? Cool. And you have sine and cosine as the axis, such as like the two parametric equations, like y equals cosine t, x equals sine t. It's not here, but let's say it was, yeah, or x equals cosine t, y equals cosine t, right? When t is equal to 1 and sine, okay, so when does, at what values of t is one like circle formed? Well, a full a circle like that would have been formed, just like one circle. So at one point would have one loop around the circle would have been done. Well, we know that that would be like one period, because you'd repeat, for example, x values if you had like a normal, like just a circle. Just a circle, no translations, sine and cosine on either side. You'd have that. You'd start here. You'd have x and y. And after one period, as in here, what's it called again? X would come to the same point. Y would come to the same point, sorry. And here and here throughout the loop, if we're going around that way. So here we have an x and y. We've repeated y, repeated x and y, but here repeated x, repeated x. You can say that along here. It follows the sine and the cosine rule idea. So from here to here, from here back to here, what would t be? Well, we know that when what's called again, everything repeats, but we want the idea that it moves away from a value. So let's just do like the sine first. So it moves away from the value. Let's say that's the original value. It moves away from it. Here, it moves back towards it until it meets it again. It moves away from it again. Oh no, it starts to move. Yeah, it moves away from it again. The same y value, for example. Simply just for the y-axis. Then it moves back towards it. And this is one loop. And this happens every 2 pi periods. And you might think, oh, like, what's good again if I do the same thing, but like, I don't know, I pick a different point, for example, here. It moves, so I'm here, I picked here, so it moves away from it, but it repeats here, right? So I might be like, okay, so it moves, so this is the halfway point, really. It moves away from it. It moves its furthest distance away from it. Furthest distance away from it. If I did that. And then it moves back towards it. And then it moves away from it much further to its furthest distance. Away from it much further to its furthest distance. And then it moves towards it by the same distance. Back to here. Do you know what this is? Just if you're noticing that this is the start, this is the end of one wave, start of a new wave. This is the same point on the next wave and the original wave, aka 2 pi away from the first wave. Then t has a 2 pi period where it does a full loop. Now let's say that everything's translated so weirdly that this kind of loops into it, so it kind of crosses. The concept is the same, as long as these are sine and cosine, which is what you find here. This, weirdly enough, if there was no translations, because here we go, x equals 8 cosine 20t, y equals 12 sine 10t minus pi over 3. You might be tempted to try and think of this as an individual case, but remember that these are just cosine and sine curves translated from this. And while everything's been flipped and some parts have been stretched, knowing that you can use, what's called again, at least not the transformations, but the stretching really, this, the 8 and the 12, would have only made an oval instead of a circle. And the idea is the same as like when I pick these points. It takes 2 pi. If I oval, I've taken the exact same length and I've just squished it. And you know when you squish something, you know it changes the dimensions, but there is kind of a circle there. It's not really there, but it's squished and stuff. So all I've done is just squish this until the point where these have like kind of like done that. So it's still, a period is still 2 pi. If I had sine, I don't know, 8 sine t, like, and I did the exact same thing with just the y-axis, I would just get the same pattern where if I started at any point 2 pi later, I would end up back and done a whole loop, because I move away from it, I move closer to it, I move away from it again, I move closer to it, I move away from it, I move closer to it, I move away from it, I move closer to it again. So 2 pi would have been the whole circle, a whole like loop done. 2 pi is entire, you've moved back to the original position, what's called again, you've done a whole loop, right? Well, then the changing factor here, because this is just a translation, all this means is that in the y direction, you've translated all of the, because this is just a function, you translated the original you had by pi over 3. So like literally everything's just kind of, all the values of x have just been shifted plus pi over 3, which you know is just moving it that way, which is why it probably intersects with these 4 places. So you can ignore that, because if you just had without the pi over 3, it would move that way, but you'd know that the time it takes to complete a figure 8 would be the exact same as if I translated everything one that way, because there's no stretching or pulling. So I'm just going to ignore that. I'm going to remember that a period is 2 pi. That's when a complete figure 8 is going to be done. So 2 pi, what's 2 pi? 2 pi is the inner part. So if you had sine, 2 pi is the angle, right? So sine of 2 pi, and then sine of 4 pi, and whatever. Every 2 pi of the angle part, there is a repeat. So the changing part, the 20t and the 10t, they both have to equal 2 pi or a multiple of 2 pi, because that's when they would have completed a loop, kind of, yeah. 10t 2 pi. But see, this is an oval, not an oval, sorry, like this is, we're trying to find the value of t where you might be like, oh, it doesn't make any sense, but because of this like the loop, this kind of created 2 separate circles. So one of the values, which is probably the what's it called again, well, one of the values, which here is actually the y value, or the x value, I think. The x value, yes. The x value assumes it's done a circle before the y value in a way, which it has, because the y value again is doing its move away, move back, move away, move back, and said, look, I've done a circle here now. But the x value had to start, you know, like it had to start, I don't know why I crossed that out, but who cares. It had to start, like, for example, here you got an x value, you know, you move away, you come back, same x value, move away, you come back. and now like X has got repeated like twice, same with Y. Before it's done the whole thing, and like this is 2 pi. But here, if you start like here, for example, it's gonna move away, come back. Oh, sorry, it just have to like move away, come back. No, it doesn't come back, move away, and then like loop back here. I don't know. Maybe the fact that there are X intercepts will add another one, something like that, or like whatever. But the concept is because the T's are the rate of change of both of them, so we're having like, sine, no, not the cosine, the sine 10t, so we're just going to ignore the translations and stuff, cosine 20t, then like 10t, cosine 20t, and they're changing together, and they're changing. What I'm really asking is, why if there are 2 axes, why is one of them saying that there is a circle completed at one point, and the other saying there's a circle completed after? Oh, it's actually quite the opposite. One of them is going to ignore the fact that the whole loop has happened, which makes sense. If you start here, for example, the X values, in case anyway, I don't know why the X, actually think of the Y, started here, for example, and it went around, it moved towards, same thing, away, back to same thing, towards, same thing, away, back to same thing. So I guess, away, let's start here, towards, away, towards, away, towards. There are loops, okay? And every period there is a loop completed, okay? And the scalar completes a figure 8. Basically, we're told with the period when a circle is formed, and the first circle to be formed is when the first period is completed, and that's when t is the earliest, because it's the least common multiple of the 2 periods. Yeah, so basically when when you see this circle, for example, at this point, y repeats twice, x repeats no times. And that's important, because if I took this one, I said x repeats twice, y repeats twice. See? Oh, wait, not x, sorry, if I do it like that. If I pick this point, for example, x repeats once. No, yeah, y repeats once, twice, x repeats once, twice. So you're basically, sometimes one of them is going to repeat, at least one of them is going to repeat twice, throughout the whole thing. For example, yeah, once, twice, and then like there you go, once, twice, once, twice. This happens 4 times, which is ridiculous. But if you're using the periods, then you know from the original, which is basically what you're just translating, at least one of them has to repeat twice. It's logical. If you make a full circle, you're gonna make a half circle at some point, and what's it called again? One of the axes are gonna repeat twice. It depends on what point you start at to know which. Might be a formula out there somewhere. So you're choosing the least common multiple, the earliest value of t, basically, where I think it's just the earliest value of t. I don't know about the least common multiple, but the earliest value of t of the two periods. Ooh, least common multiple. Well, we assume everything to be. We're using a perfect circle, so we're using 2 pi for this one, 2 pi for the other one, eventually. Because it'll always be pushed out into a circle. Find the least common multiple, so the point we pick, y repeats so a certain amount of times, so a certain amount of times. So when one of them, because it's an oval, completes 2 pi, so a full period, then the circle must have been formed, because after one of them does what repeats once, repeats twice, when one of them repeats twice, then a full circle must have been formed. Here, of course, with the loop-de-loop, you might be like, oh, but like one of them, like it's repeating, I don't know, once, twice, or twice from there, but like once. Oh, why is it only repeating twice? X is repeating once, twice, 3 times, 4 times. Okay, yeah. Okay. So you see that y repeats twice, x repeats 4 times, y has repeats 4 times. The whole loop-de-loop happens with 1x. Am I freaking out? Because, y is 2, x is 4, y is smaller than 2, 2 is the least common multiple. But you're not thinking about the x and y's and how many times you're repeating. You're thinking about the t and how many times it's repeating. T is drawing itself 2 lovely, lovely curves. I'm thinking about it like this. I'm thinking about it like sine curves and stuff. So it's just taking this and then flipping it and playing around with it and making this. And a period is still 2 pi. And one of them repeating twice. So basically, after one of them has completed a circle, after one of them has completed its period, a full circle is formed, or a full loop de loop is formed. However you see it, because the other one would have just been, if it was just sine t, cosine t, it would have done that. Gone round, made a circle like that. So the whole thing, 2 pi. 2 pi is a period when at least one of them has completed a period, a full circle is formed, because depending on where you pick around the loop, again, there will be varying number of repeats, and you just want, there'll be basically, varying number of repeats, and you just want the one. You just want the one that. You just want the smallest period because it's the earliest point where a circle is formed. And it tells you when a circle is formed. So you have to think about the x and the y, because if we just thought about the y, thought about the x in this case, you'd be looking for when x repeated twice. X repeats once, twice. Cool. You'd also be thinking about when y repeats twice. You'd think y only repeats once. You'd be going around 2 times just so that you could you'd be going around 2 times just so that you can say that you've completed a circle, which is not true. So you're finding the lowest period, the lowest lowest period when lowest period between x and y. So taking it back to this question, a period is 2 pi. I told you already, this is just a translation, so we don't have to think about that. 20t is equal to 2 pi. So 20t is equal to 2 pi. So, I did some working out earlier. Oh, that's horrific. So, if we look inside here, 20t is equal to 2 pi. Because this is the angle, cosine theta, this is the x-axis, cosine theta being the y-axis, the value of x. Again, I'm ignoring that because that just turns it into an oval. We saw that the same thing occurs in an oval. Theta, cosine theta, every 2 pi there is a repeat. Cool. So this is not theta. Theta is equal to 20t. So when theta is 0, 20t is equal to 0. But when theta is equal to 2 pi, which is when there is, which is a complete period, we want to know, we just, that's one complete period. And then the multiples of that period is when there's all the loops. So 1 loop, 2 loop, 3 loop. Sorry, 1 8 figure, 2 8 figure, 3 8 figure, because it's not just a circle. Then t is equal to 1/10 for pi. So when every time t increased by 10th pi, so 10th pi, 2/10 pi, 3/10 pi, assuming that, this is not the limiting factor, like y was in that circle, assuming that x is not the limiting factor, then that would be the period of the circle, or it's not circle, the figure eight, but still, that would be when a full figure eight is completed. So the period for this, for y, is 10t, which is equal to, why on earth did they expect you to just know this? This must be a challenge question. It's an example. That's horrific. That's actually horrific. Okay, 10t, 2 pi. T is equal to a 5th pi. I'm giving AQA Excel, ideas. Okay, t is equal to 5th pi. This is the period, so the supposed time it takes to complete a full figure eight. But we know that one of these is like a lie. A circle can be completed with just one of the values, either x or y, doing a full loop. And this is the lower value. So a full loop, I say, and by loop I mean like a complete figure eight, has been completed by x in 1/10 pi time. That's the time it takes to complete a full loop, and y is just like the limiting factor. So the time it takes no they've picked, I'm sorry, I'm completely wrong. Yeah, sure, but every 2 pi, whether or not there's a repeat, because if you do a 2 pi here, y repeats once during that 2 pi there, you see, even though a full period has been completed, though it hasn't. But starting from 0 to here, a full period is being completed. Y is only repeated once. The period is still 2 pi. So you're just trying to find the value of t where both x and y have completed a period, therefore a full loop-the-loop is formed rather than a full circle. circle. So basically you're picking the biggest number. You pick the biggest number because one of them pick the biggest number because a period means um, a circle has been completed. You're trying to find the value where in this weird oval shaped thing a circle has been completed. And I don't know why you know, I mean I get why my reasoning was wrong, but I don't know why what do I don't know why. I don't know why when we